Alright folks, this is Eric coming from Kansas again. Little another update on this battery backup power cabinet here that been putting together. Previous video did some high capacity testing on it to see what it would power, and it came through with flying colors so far. I actually did decide to charge the charging function on this, which is a good thing probably, before I shipped it off. And so I hooked up a computer cord. It's only 18 gauge wire, so probably only handles 10 amps at 120 volts AC. So I didn't put a whole lot of load on it, but it does work. Charge batteries back up. The original setting, batteries were sitting at 13.5, and it's on sorry, the focus there. And the let's see if we can get a light on here. The green light for the float charging functionality is on. The light just to the right of that, where it says fast charge, it's kind of a yellowish light when that's on, so that light is on when it's just charging in bulk. And the setting on it for bulk charging from the factory, at least the way I got this Ames inverter, was right at about 15 amps. And I think the highest charge rate this thing can do is about 75 amps. So it's set pretty low, which is good. And I'm just going to leave it there, because that's about 200 watts of power at 12 volts or so. And I'm just going to leave it there. That means it'd take about a little over a day to charge this 400 amp hour bank up to full charge if it was fully depleted. And I figure that was pretty good. And if there's a power outage, it'll take about a day to charge back up, and I figure that's plenty. I don't need to charge any faster than that for a mom, so I'm gonna leave it there. And what I'm gonna do now is I'm actually gonna do a capacity test. So this thing is sitting here at full charge at 13.5 volts, and I don't know why the focus, there we go. So it's putting in about 0.3 amps to keep it on float, looks like. And 4 watts there. Okay, so we're at 99%. I bet it goes back and forth between 99.9 and 100%, I'm guessing, because I saw this thing at 13.4 volts earlier this morning, so it must vary. But anyway, so it's fully charged, at least from what I can tell, and the full charge voltage I set it as 14.1 volts, so it's not a full charge, but it's pretty close. So what I'm going to do now is I'm going to hook up this, I'm going to unplug the power cord here so that's inverting. So now that other light for float charge is off, and it's in inverter mode. And plug in this heat gun here that pulls about, I don't know, 750, 800 watts, maybe something like that on the low setting. So get that plugged in here with one hand. And I don't know, it's going to take a while to deplete this battery pack on low setting, so I might go to high at some point. But we're going to turn it on here, and it's going to pull about 900 watts from the batteries. And there's the amp hour rating. So we're going to see how far this goes down. and what voltage it gets to. So I'll give you some updates here in the middle, and at the end we'll see what happens. And so right when I turn that on, obviously you saw it started about 900 watts from the batteries. Battery voltage went down to 12.9. So that's where it started at in terms of being loaded. And it's pulling about 70 amps from the batteries. So this is going to take more than 5 hours, so I might bump it up to the high setting here after a little bit if I'm comfortable with the how hot if the wire is getting the temperature to them. I might bump it up to the high setting here. So we'll see how this goes. Alright, so we're about an hour through this test here. We're still pulling about, let's see, 70 amps from the batteries. We're down 69 amp hours. And just checking some things out here in the batteries. So these 4-gauge wires, which are a little small for each of these batteries, the connections here on the positive side are warm. I'd say they're 85 or 90 degrees Fahrenheit. This one over here is a little bit warmer. It feels like 90 or 95. These 4-aught wires aren't warm at all, not surprisingly. And the inverter casing is, you know, it's a little warm. It's maybe 80 degrees Fahrenheit, maybe something like that. One interesting thing though I found is that so supposedly these batteries are pulling the amperage being pulled from each of them is about the same, but when I put my hand on this one over here, I don't feel any warmth at all. It's nice and cool to touch, room temp. This one over here, sorry, get in the way of the light there. This one over here, definitely a lot warmer. It's maybe 85, I'm guessing, maybe 80 Fahrenheit. Definitely 10 to 20 degrees warmer than that BMS. So that this BMS is warmer than that one. So thought that was a bit interesting. I'll continue to keep an eye on it. I may bump up the load here a little bit to see what happens, but I think I'll let this run another hour or so on this heat gun on low and see how it goes. So yeah, we're still pulling about 900 watts from the batteries, and our battery voltage is down to 12.5756, and we were at 12.9 when it started. So still doing pretty good. Okay folks, so we're about a little over 2 hours into the test here, down to 158, 159 amp hours, and out of a 400 amp hour rated battery, so it's 57%. I don't know why it only shows 0.4 hours left. That doesn't make sense. Anyway, down to 12.45 volts. Still pulling about 70 amps, 900 watts. So, been doing some checking over the system here. I haven't changed the load. It's still on, heat gun still on low here. And so even these 4-aught gauge wires are getting warm over here for some reason. I'm guessing maybe I'm a little surprised because it's maybe it's not that big of a deal because it's a 12 volt system versus 24 volt, which I have downstairs. So there's more of a voltage drop going on in this system here. But I mean they're around 85 degrees Fahrenheit, something like that. They're just warm, not not too bad, but kind of interesting. This inverter's gotten maybe a little bit warmer, but not too bad. It's hanging in there nicely. And I was down here checking some voltages across the batteries, and I guess this is why you do capacity tests, so you can test out the system. And I think I found a bad cell, so I'm going to go through some cell voltages here for you. So this first cell over here, this one on the far left here of this 12 volt bank, is reading 3.175. I'm just going to go through them here. So the next one over is 3.17169. The next one over is about the same, 3.17. And the next one over is 3.087, so that's a little bit off, not too bad. Less than a 0.1 volts off for a load testing. This other bank though is a little more interesting. This bank over here, so that low one was this guy right here, 3.087. So I'm going to hook up the far one on this other bank, and we'll see what that shows us here. Sorry, I get these hooked up here. These alligator clips. All right, 3.22. Next one is 3.224. The next one is 3.225, so they're all pretty close. And this last one is 2.914. So this one is 0.3 volts off, which is pretty concerning. It's getting down, it's much closer to the 2.5 volts cutoff, or maybe I think these might cut off at 2.7 from what it said on the internet, these BMSs, but so that's a little concerning. So I'm gonna keep an eye on this cell and maybe this one too to see what's going on, but it's kind of unfortunate that it's doing that, but I guess we'll see how it holds in there. Again, we're at about 160 amp hours now, and we started at 14.1 volt was the charge voltage I put this at, and it floated overnight, and I started it probably about 2.5 hours ago, so we'll see how it goes. Yeah, I guess I wasn't going to do this here, but it's good that I did, so we can see what's going on here and see if we need to contact the place I got the batteries from. Anyway, stay tuned. We'll see how this ends up. One thing I also want to mention, folks, is the voltage drop across the system here. So right now I'm measuring about 12.6 volts on this cell and this cell, so they're pretty even. And we're measuring 12.43 on the shunt here over in this DC disconnect box. So 12.43 between this connection and this connection. And then on the inverter we got up here we got 12.34. So about a 0.25 volt drop from these batteries up to the inverter. Just so you know, so that that's probably where some of the heat's coming from, is that wattage loss there. But wanted to update you on that as well. And I did the voltage, it says on this battery meter, I did check it with this voltmeter, and it's 1/100th of a volt difference. So what this is reading is pretty close to what this is. So just so you're aware, because I was obviously using this to measure at the batteries and at the inverter. So I'll update you on that as well. Stay tuned. Alright folks, so I decided to bump up the setting on this heat gun. It's on high now. And instead of pulling 900 watts, it's pulling 1.66 kilowatts, which is 137 amps from this 12 volt bank. And we're down to 182 amp hours. And I've been watching this cell here. This cell I thought was not great, but what I'm wondering now is I forgot to check these cells, the cell voltages individually when I started this test, and to make sure it was top balanced, and I didn't do that, so shame on me for not doing that. That's my bad. So anyway, but I've been watching this cell, and it was at 2.908 or 2.915 or something around that area, and it was kind of juggling around there for a little bit, and now it went up to about almost 2.95. So I'm guessing this BMS is doing something to it. So I'm going to measure the other voltages here to see what's going on here, see if they got a little closer. So let's go to the one behind it. Yeah, 3.156, so it is a little closer. It's down to 0.2 volt difference now, which is interesting. And we do have a higher voltage drop across these, from these batteries to the inverter now. It's over, well, where I got 12.4 at the batteries, we got 12.0 here, so it's about 0.4 difference between this batteries and the stuff in this box, and I'm sure it's more than 0.4 when you measure at the inverter. I haven't done that yet, but anyway, so the next cell back is 3.15, and we're still at 2.9, about 0.2 difference between this cell and the cell behind it. So I'm going to go to the cell third from the front. Let's see what that is, if I can get it on here. 3.155 also. And if we go to the other one, 146. So, yeah, that was surprising. Now we're only 0.2 difference between all the cells, so maybe it's not that bad between all of them. I'm going to check this other bank and see if I see anything interesting, and we'll keep an eye on this. And it's been running on this higher load for about 5 minutes now, so we'll see how it goes. So I just checked this other bank, and this one's still lower. It's at 2.98 now. These other ones are about 3.1, just a little over 3.1, so we're still around 3.1 or 0.1 volts off here, and we're 0.2 volts off here between the cells, max difference. And just check some warmth, and I forgot to mention this whole time that these bus bars are doing pretty good. That they're a skosh warm, but these bus bars are doing pretty good. They got 70 amps being pulled on them now on each bank. This BMS is still warmer than this one, but this one is definitely getting warmer now, and it was, but even before I moved to the higher load, so they were kind of evening out. But still, this one's probably about 95, 100 degrees now, somewhere in there. It's getting pretty warm. Yeah, and those cables on there, not too bad. The 7-gauge cables that it came with. So we'll keep an eye on this. All right, folks, another update here. So this This cell I thought was not great here in front. It's now up to 2.99. I saw it above 3 there briefly actually. So this balancer, I guess, is doing its job. I'm surprised it can. I don't know if it's. I guess it's passing a bunch of current through that balance wire, but I don't know. It's like it when I pumped up the juice coming out of this heat gun, it kind of woke up, so it was kind of interesting. So now this cell right here is the lowest. This one's 2.98 now. So I'm keeping an eye on this one here, this far one here, more so now. Sorry. Keep my wires uncrossed here. Okay. That one's up about 2.96. So that's what I'm watching now. Things are quite a bit warmer as I've left it in this higher mode. You can see it's a nice glow to it. So we started about, well, I got my watches in 24-hour time. Started about 13:45. Now we're at 14:15 hours, which is 1:45 to 2:15. So about 30 minutes now at this higher load. And this guy right here, I can't keep my fingers on it long enough to. It's too hot to touch if I keep my fingers on there too long. So it's probably 120, 130 degrees Fahrenheit now. Pretty warm. Same thing with that one back there. That's even hotter. By 130, 125, 130. And that BMS still not doing too bad back there. I'd say both BMSs are about the same in terms of warmth. And since this heat gun is adding heat to this room, I've got this fan going, which is pulling power from the batteries too. So I got a little aux power cooling here. But anyway, that's what I got going on now. We're at 240 amp hours down, 35% left, and 11.86 volts. And that is pretty close to the voltage at this inverter charger. And we got about, I'd say about 0.35 to 0.4 volts between here and here, voltage drop. And these terminals in this DC disconnect box are quite a bit warmer. I'm surprised, but I guess that's what you get with a 12-volt system. That's why people go to 24 volt and 48 volt systems, because of the voltage drop and the energy loss they're in. So that's an update, and we'll catch back up here in a little bit. Alright folks, we're at I don't know how long we've been doing this, but we're at 287 amp hours down out of 400 rated. And this cell right here is the lowest again. It's at 2.66 volts now, so it's getting down there. So I'm going to watch this more closely now. And although it did go back up, I don't know. I'm going to watch it more closely, and we'll see where we're at. It's been about 45 minutes, 50 minutes at this higher load for the heat gun. But we're still at one point. Now we're at a little higher because we're using that fan. About 1.7 kilowatts. Sorry about the focus there. We got 290 amp hours. We're on 11.2 volts. 150 amps now because the voltage has gone down so low. So, that's interesting. The voltage on this went back up. Anyway, keep watching this, and we'll see how it goes. Oh, we're getting to a low voltage situation here. Yeah, I think that's the low voltage alarm. We're only at 303 amp hours, unfortunately, so we'll see what happens here, but I guess this thing's going to shut off pretty soon. Yeah. But once again, shame on me for not checking the cell voltages before I got started here to see if we were top balanced. But it might be 100 amp hours down. Let's see where this shuts off at. But this inverter charger, since because of the voltage drop, now we're getting the voltage alarm. I think I set up for this battery monitor. So I bet things will shut down before these BMSs shut off. I got down below 2.5 volts on that cell. We'll wait till 9. We'll probably get down to 10.1. That inverter charger is going to be at 10. And there we go. More lights shut off. All right, so shut off at 10.2 volts before these BMSs shut everything off. I'm not sure what voltage we got down to on the battery cell, but 309.5 amp hours. Okay, well, I think I'm going to charge this thing back up and see what we get this next time here in terms of cell voltages at the top. I'll check them at the bottom here, and we'll see where we're at, and then we'll charge this thing back up. So we'll have to redo this again. So, yeah, that's all we got for now. Hope you find that interesting. Maybe a bit long, but that's what we have to do here to make sure these batteries do what we want them to do. So, without further ado, grace and peace be with you. We'll talk to you later.